Hey everyone, this is going to be another Back to the Basics tutorial, this time focusing on loops in C++. If you recall, a few weeks ago I actually did a tutorial on conditional statements, so if, else, and then else if statements using C++. This is just material for people who are new to programming or new to a computer science program that needs some additional help. It doesn't really focus on a particular task that is of too much value, but the material is going to be repetitive. And hopefully it kind of makes it click in your head when it comes to general programming concepts that are going to be used throughout your career. So this time, again, we're going to be using loops. A previous tutorial I did was conditional statements. So definitely review all of them if you have a chance and if you're still learning the very basic material. So I do have a basic project up. I'm using Visual Studio Code. Visual Studio Code is already configured for C++ development. If you want to configure Visual Studio Code, go ahead and check out a previous tutorial that I wrote. With that said, so what I'm going to do is I'm going to start by doing various loops. So we're going to be exploring 3 different loops. We're going to be exploring a for loop, a while loop, and a do-while loop. So starting with the for loop, I'm going to show you what it looks like, and we're going to see a few for loop examples and why it's important. So inside the main function, let's go ahead and do the following. So we're going to say int I equals 0. Or if we really wanted to, we're just going to say int I. We're going to say for I equals 0, I less than 10, I plus plus. So what we're saying here is we're saying, you know what, we've declared I. Now we're setting it equal to 0. We're going to loop for as long as I is going to be less than 10. But every loop cycle, we're going to say that we're going to increase I by 1. So what we're going to do is we're just going to print out that value of I. So we're going to say cout. We're going to say for counter value. So we're going to be tracking I. And we're basically just going to print out what I equals. So we're going to say I, and then we're going to say new line character, so end line. So let's go ahead and try to run it and see what we end up with. I'm going to say run task because I already have my Visual Studio Code configured. I'm going to say run. And down inside of my terminal logs, it's now looping and printing out 0 through 9. You'll notice that I did say 10, but I said less than 10. So I will never actually print out 10 because the loop will stop as soon as I equals 10. That's why we're saying 0 through 9. Now, if I wanted to include 10 in that loop set, I can say less than or equal to 10. So I'm going to say run it again. Let's say loops run. And this time around, it printed out 0 through 10. So very convenient. Now, if I wanted to simplify things, you'll notice that I declared I on a separate line. If I wanted to, I could remove line 6. And directly in the for loop, I can say int I equals 0. So now I've declared it and I've set it directly in the for loop, and we'll get the same results. So now that we have that, let's look at another example. So we have a loop that's increasing. What about if we wanted to do a loop that decreases? So let's say we wanted to count backwards from 10. What would that look like? So in this case, I'm going to say I equal to 10, and I'm going to say that the loop is going to, instead of increase by 1, it's going to decrease by 1. So I minus minus. Now, when I start at 10 and I'm subtracting, you know what? I is always going to be less than 10, or less than or equal to 10 in this example. So what I want to say is I want to say while I is greater than, let's say 0 this time around. So we're looping backwards. And then for as long as I is greater than 0, the loop is going to print out. So I'm going to save it and I'm going to run it. And we're going to see what we get. So I ran it, and it started at 10, and it stopped at 1. Because remember, as soon as I equals 0, the loop is going to exit. It's going to stop. But if I wanted to, I can say I greater than or equal to 0, and I can try running it again. And this time around, it goes from 10 all the way down to 0. So you'll notice that we counted backwards. And remember, what we did is we changed the loop iteration. So we're iterating, we're subtracting by 1. And we are, this time, instead of saying less than a number, we're saying greater than a number because we're going backwards. Now let's look at another example. What if we don't want to add or subtract a single value? What if we wanted to add or do some kind of other operation to increase our counter? So we can do that in a for loop. We don't need a different type of loop for that. So let's go ahead and start at 0 again. We're going to say I is less than 10. So it's going to be 0 through 9, remember, 0 through 9, because I don't have an equal sign in there. And this time around, what I'm going to do is I'm going to say I plus equals 2. So what we're saying is whatever I is, say I equals I plus 2. That's essentially what this is saying. So let me write it out so that way it makes more sense. This I plus equals 2 is the same thing as saying I equals I plus 2. We're just shorthanding it. So we're saying I plus equals 2, and we're going to print it out. So let's go ahead and give it a shot. So we're going to say terminal run task loops run, and this time around it only printed out what is this, 5 times, because we're increasing our loop value by 2. It doesn't mean that I is just going to increase by 1 again, but or whatever. We're not going to loop through it 10 times or 9 times this time. We're saying that we're going to loop however many times is possible while we're increasing at that given rate. So that's how many we printed out. So if I wanted to, I can change this to say 3, or let's go ahead and just say 5 maybe, and run it. This time around, it only printed out twice, because after those 2 times, I is now going to be greater than 5 or greater than 10. So we were able to increase. We could do a multiplication in here. We could do a subtraction. We could do whatever we wanted. But it's just for us, we don't have to worry about what we're increasing by. So let's take a look at another example. So another example is, you're often going to need to loop through arrays. So arrays are going to be common when it comes to your developer career. So we're going to use that as an example. So let's go ahead and define an array of integers. So we're going to say int. Let's call it values. And this array is going to be initialized with the following values. So we're going to say 2, 4, 6, and 8. And our goal is going to be to loop through them. But we're going to do it in a very efficient manner. And again, we're going to be using a for loop for now. We're going to switch to different loops soon. But I just want to kind of give you as many examples as possible without getting too boring on how to use a for loop. Because the more you see it done, the easier it's going to become. At least that's how it is for me. So I have my array. Now what we want to do is we need to figure out, well, what's the size of this array? We don't want to hard code 5 or 4. That's not good, because if we ever wanted to increase the elements in this array, then we have to kind of keep track of that value, which isn't good long term. So what we can actually do is we can actually determine the size using some common C and C++ functions. So let's go ahead and create another variable. I'm going to call it size. This is going to represent the size of our array, or the length. And what we can do is we can just say size equals size of, and we can say values. And this isn't all of it, but I'm going to show you what this does for us. So I'm going to comment out our loop, so that way you can see what exactly size of does in case this is your first exposure to it. But I'm going to say cout, and I'm just going to say size. I'm going to keep it simple, and I'm going to run it. So it printed out 16. So obviously this is only 4 values, not 16. So why did it print out 16? It printed out 16 because each element in this integer array is going to be of 4 bytes. So the size is in bytes. So this is 16 bytes, not 16 values. So what we can actually do is we can fix this. So we can actually do simple division. So we can say divided by size of, and we can do pointer values. Or if we really wanted to, we could do values and then the first element. So what that's going to do is it's detecting what's the size of one particular value in this array. So I'm just going to use pointer values, and I'm going to run it again. And I'll show you both ways. I'm just going to say run task, run, and now it's 4. So that's an accurate description of how many items we actually have in our array. So I'm going to change this. I'm also going to just say value 0. So we're looking at the first element in that array. This, of course, assumes that we do have values in our array, whereas the pointer is a little more lenient. But let's go ahead and say run task. Again, it says 4. So I'm just gonna leave it as a pointer. That's my preferred. And we're gonna start our loop. So we know our size. We know that and if this changed, I can say, you know what? Let's go ahead and say 10. The size will change with it, and we don't ever have to worry about manually defining that size. So let's go back into our for loop. And we're gonna loop to the size. So we're gonna say we're gonna start at 0, because when we're working with arrays in C++, the index starts at 0. And as far as our loop size, we're gonna say I is less than size, because size in this case is 5. But if we're looping 0 and we're saying less than or equal to 5, we're going to get an error, because it's gonna actually loop 6 times, and that's going to give us an out of bounds error. And I'll actually show that. Let's first change this back to I++. Let's go ahead and say let's go ahead and change our print statement here. Let's go ahead and wipe this out a bit. Let's go ahead and say I. We're going to say colon, and then we're going to say value. So we're going to do a few things here. So we're going to say, we're going to print out the index, so the I value, and then we're going to print out the actual value at that I. And we're going to do that one line at a time. But like I said, this should fail because we should be out of bounds. So let's go ahead and run the task. So it doesn't look like it went out of bounds. It should. So it looks like we didn't explicitly get an out of bounds error when we ran it, because we didn't explicitly say the size of our array, which is fine. Every language is going to treat it a little differently, but just note that technically this would be out of bounds even if we didn't define it. So what we want to do is we want to do less than size, because remember 0 through 4 is going to be technically 5 elements. So 5, because 0 counts as a number as well. So I is less than size. So if I printed it out, I ran run task. It did print out every value in my array, and it printed out the index that went with it. So this is pretty useful. So let's go ahead and take a look at another example. Let's look at an example where maybe we want to print out rows and columns. So these examples don't have any real value to them. It's just different scenarios that kind of get you familiar with using a for loop in particular in this example. So let's go ahead and make some changes. And you'll notice that I am deleting my previous loops as we go forward. Just go ahead and rewind the video, and you can always go back to see what we did. So this time I'm gonna wipe it out here. I'm gonna start fresh. I'm gonna say for. I'm gonna say int. So this is gonna be rows and columns. So we're gonna say row equals 0. So instead of I, we're calling the variable row. We're gonna say row is less than 10. And we're going to say row plus plus. So everything we've seen so far. We're gonna see out the current row, and we're going to just add a let's add a colon there, and we won't do a terminating character, so we won't do an end line. But we want to print out rows and columns, so we're going to do a nested loop. So we're going to say a loop inside of a loop. So we're going to say for. This time we're going to call it int column, and we're going to say equals 0, column less than 10, column plus plus. So this is just like the exterior loop. So just like the rows loop, we're going to say cout, we're going to say column, and we're just going to add a space between them. So what's going to happen is it's going to hopefully print out the row number, and then it's going to print out every column in that row before recycling. So it's going to say we're at interval 0. It's going to print out 0 here. It's going to loop 10 times, and then it's going to go back up here. It's going to change it to 1. It's going to loop 10 times again, and it's going to keep going until essentially this top exterior level loop is finished. So before it recycles the loop here, we're just going to say cout end line. So we're going to add a new line character. So let's go ahead and try to run it. We're going to say loops run. And this is what it did. So we have our row. on the left, separated by a colon, and then we just have the columns. So we have it goes 0 through 9, but we have 10 columns here. So not so bad. You'll learn in a future computer science class or programming class that you probably don't want to nest loops like this because it's not efficient. But that is a subject for another day. Go ahead, and if you're learning about programming, go to town on it. Go ahead and use as many nesting as you want until you reach that next level in your development career on why it may not be a good thing. So let's look at another example. Let's look at an example where we have now conditional logic. So this would be kind of extending what we saw in the previous video with if statements, but we're going to use that inside of a loop. So let's go ahead and remove a lot of this. Let's go back to I, because people usually use I, J, K for these loops. For your variable names, it doesn't really matter. My suggestion is to name these variables something that is representative of what you're trying to do. Like you saw in our row column example, I actually called it rows and columns, but that's up to you to decide. So I'm going to do this very standard loop. We're going to loop 10 times again. But what we're going to do is we want to say, well, let's print out all of if the number is odd or if the number is even. So 2, 4, 6, 8, etc. Would be even. So let's do an if statement. So we're going to say if, and we're going to say I, and we're going to say modulus. So modulus would be a remainder in division. So modulus is that percent sign. We're going to say modulus 2. So if we divide by 2, and it has 0 remainder, that means that it's an even number. So let's go ahead and see what it looks like. So we're going to say cout. We're going to say I, so the index or the element. We're going to say even, and L. Otherwise, what we want to do is we want to print out that it's an odd number. So I'm going to say else. And in this case, it's either going to be even or odd. I can extend it even further because I think there might be some debate on whether 0 is an even or odd number. So if I wanted to, I could do an else if. But we're just going to say it's going to be even or odd. We're not going to get into the nitty-gritty details on what 0 actually is. So we're going to say cout. We're going to say I, and we're going to say that it is odd. So let's go ahead and print it out. So we're going to run it. So in this case, you could say 0 is even, 1 is odd, 2 even, and so on and so forth. So the modulus is how we determine that. So if we do a modulus 2 and it is something other than 0, it is going to be an odd number because it has a remainder. Because modulus lets you do work with remainders in division. So that's an example. I mean, the example here was not to teach you about modulus. It was just to show you that, hey, you can have now if statements, so conditional statements inside of your loops to determine whether or not pieces of code actually execute. So I think I've exhausted the for loop probably. So we're going to switch on to another type of loop. So again, there's 3 loops that we're going to explore in this particular tutorial. The next loop we're actually going to explore is going to be the while loop. So different kind of loop, different setup. So I'm actually going to wipe this out, and we're going to see the very basic example. So it's going to look familiar to us because we've explored a lot of this in the for loop already. This is just an alternative way to handle things. So I'm going to say int I equals 0, and I'm going to say while I is less than 10. So you'll notice that I'm not actually setting I inside of this while. I'm not increasing it inside of this line 7. So the setup is going to be a little different. So all we're doing is we're setting a condition on when to stop this particular loop. So we're going to say cout, and we're just going to say while counter value. And we're going to say I and L. So this, in theory, right here, will loop forever. What I mean by this is, while I is 0, we're looping until I is less than 10, but we're never actually increasing I, so it'll just go on forever, which we don't particularly want. So what we can do is we can say I plus plus. So at the end of the loop, it's going to increase I, and it's going to redo the loop until I is now greater than or equal to 10. So let's try to run it and see what we get. So you can see a while counter value, it started at 0, it went till 9. So just like what we saw in the for loop, because we didn't say I is less than or equal to 10, but it's just a different way to accomplish things. So let's look at another example. This example is going to count backwards. So let's say I is equal to 10. Remember, if I'm going to say, well, I is less than 10, it's never, well, it's going to fail this one time because I is currently 10. But we want to change things. So I'm going to say while I is greater than 0. And this time around, I'm just going to say while I equals I minus 1. So it's going to be I minus minus. So I'm going to save it. I'm going to run it. And this time it counted backwards. It didn't print out 0 because we didn't say greater than or equal to 0. So we could, but we aren't for this example. So that was a very simple 2 different while loops. We're going to do another example. We're going to do the column and rows example again to show you that, hey, whatever you do in that for loop is still going to be possible in a while loop. So it's going to be you decide what you want to use for the certain task at hand. So let's go ahead and wipe this out. I'm going to say int row equals 0. I'm going to say column equals 0. So these are both integer values. I'm going to say while row less than 10. So just like our rows and columns example. I'm going to see out row, and I'm going to delimit it with this colon character without the new line. I'm going to say while column is less than 10. So what it's going to do is it's going to enter this first while loop because it's 0. So it's going to enter. It's going to print out the row, which is 0, and then it's going to enter this this column while loop starting at 0, and we're going to print it out. So we're going to say see out column, and we're going to separate it by a space character, and at the end of it we're going to say column plus plus. You'll notice that column is increasing inside of the inner while loop. Because remember, it's going to enter this first while loop, and then it's going to enter this second while loop, and they don't run in parallel. This while loop doesn't continue until the inner while loop has finished, and the inner while loop will never finish unless you increase column inside of that while loop, or you issue a break or something similar. So when the while loop is finished, because column equals is equal to or greater than 10. We can now increase the row because we're getting ready to reissue this loop, so we're getting ready to restart it. But column is now equal to 10 because we've increased it, so we need to reset it. So we're going to say column equals 0. We've now reset it. It doesn't automatically reset like it does in a for loop. And then we're going to say see out, and we're going to say end L. So let's go ahead and try to run it and see what we get. So you'll notice that this looks pretty familiar. It's what we saw in the for loop example, but this time we're using a while loop. We have the rows on the left, and then we have 10 columns on the right. So a little more complicated of an example, but you can see that while loops are still very powerful things. So now let's jump into the DoWhile, because I can easily do 100 more of these while loop examples, but they're going to look very familiar to you in terms of for loop because of what we've already seen. So we're gonna go into our third loop example, which is the DoWhile loop. So DoWhile is probably a little different than what we've seen so far, but it still accomplishes a similar task. So let's go ahead and say in this example, we're going to say I is equal to 0. And I didn't actually include I, so let's go ahead and include I. And what I'm going to do is I'm going to say do. Notice I'm not saying while or for. I'm going to say do. And at the end of the do, I'm going to say while. I'm going to say I less than 10. So in the previous example, I said while I less than 10. This time I'm saying do while I is less than 10. So what we're saying is let's go ahead and say with this example. If I is equal to 10 and we enter this do loop, it will do one iteration because it will not check to see if I is less than 10 until the end of this code block. Whereas if I said while I equals 10, it first checks to see if I is less than 10. So the purpose of the do while loop is to do one iteration before doing its check here. So if I wanted to, let's go ahead and say cout. Let's go ahead and say do while counter value. And let's just go ahead and print out I, and let's go ahead and say end L. So I'm going to run it. You'll see that it is going to print it out even though that this while is not valid. So let's go ahead and say terminal run. So it said do while counter is 10 and it stopped. So it should, if this was a while or a for loop, it wouldn't have even printed anything out in this scenario. So let's change it up again. So we're going to say I equals 0. It's still going to enter, but it's going to go on forever because I is not increasing. So let's go ahead and increase I. So let's go ahead and run it. Run task. And it looped from 0 all the way till 9, and then it stopped. So the kind of thing that I want you to remember here is the do while loop. It's going to execute at least once. So whatever happens at the end is up to you. But whatever's inside this main code block 8, 9 will execute at least one time. Unless, of course, you do have some kind of condition statement that maybe has a terminating characteristics like a break, then things might be different. But in this example, the do while loop, it's going to execute at least one time, whereas the while loop and the for loop is going to execute based on the criteria in that particular condition. And I won't be doing more do while loops. Hopefully you get the idea here. But we just saw quite a few looping examples. Hopefully just by seeing them over and over again, it kind of gives you ideas on how to actually use them. Like I said, if you wanted to learn more about conditional statements like if, else, and else if, check out my other C++ basics video. Or if you actually like Visual Studio Code like I'm using right now, do a search on my channel for Visual Studio Code C++ configuration. Because I actually like Visual Studio Code versus the alternatives when it comes to C++ development.